Hey guys, today we're going to see problem number 225, implement stack using queues. As you can see, this is a very easy problem. And let's see the description. Implement the following operations of a stack using queues. Look at the plural. They're saying queues. So push of X, push element onto the stack, and pop means removes the element on top of the stack, and top means gets the top element, and empty means returns whether the stack is empty. So basically the same operations of the stack we have to implement using queues. And the example where they've given us, like they've instantiating a class variable stack, okay, and they are pushing in one, so one will be at the top of the stack, and they are pushing two, which means two will be at the top of the stack, because in stack last in becomes the top element, right? It's a last in first out structure. And then we are getting top, which means whatever is inserted recently we are at the top, so we'll return true. And then we're trying to pop it, which means 2 will be popped and the popped element will be returned, so that's why they're returning as true. And then we're checking is stack empty. No, stack is not empty because there is one more element inside it. And in notes they're saying that you must only use standard operations of a queue, which means only to push to back, because in a queue you actually push to back. And whenever we delete it, right, we pop it or pick it from the front. You peek during top, right, and you pop it from the front during DQ. And size and SMT operations are valid. So depending on the language, queue may not be supported natively. I'm going to use Java, so we can use linked list class to basically simulate the queue. And you may assume that all operations are valid. For example, no top or pop operations will be called in an empty stack. So the basic idea is to have two stacks, right? And the problem already talks of having plural stacks, implement stack using queues, right? So what we're going to do is we're going to have two queues. And before that, let me indicate that this will be your stack. Okay, let's say we have a stack like this. So let's say I've inserted one. So in our approach, we're going to make the push operation constantly. So I'll basically explain it in a minute. So we've got two stacks. Whenever an element is there, we'll add it to the second stack. Okay, and as long as there are no elements in Q1, okay, if there are any elements in Q1, we'll add it. We'll basically pop it from Q1 and add it to Q1. So right now we do not have any elements in Q1, so we cannot add anything the back of Q2. So what we will do is we'll just swap Q1 and Q2. So we'll just say Q1 is this and Q2 is this. Okay, so that is what we will do in a push operation. So let's say I'm inserting 2. So whatever the element that is inserted, I'll put it in the empty Q2. And now if you see the Q1 is having an element. So as long as this is not empty, we'll remove elements from Q1 and add it to Q2. So we'll remove 1 and we'll add it to Q2. And then we will mark this as Q1 and then we'll mark this as Q2, basically swap. Okay. And if you observe, whenever we're doing this, right, the Q1 queue is actually mimicking the stack. Okay, so 2 is the top of the stack and 2 is the top of the stack, and when you pick it you'll actually get 2, right? And let's say I'm inserting 3, so we'll insert it into the empty queue, so 3, and we see that in Q1 it is not empty, so we have to basically pop all elements and add it to the end of the queue. So 3 2 1 will remove and Q1 will become empty, so empty stack will empty queue, we have to make it as Q2, and then this will be Q1. So let's say, so this is how the push operation works. Okay, now let's say I want to delete 3, so 3 is at the top of the stack and it is easy to remove from the stack. And here in Q1, so for pop operations, what you're going to do is you're going to remove it from the front of the queue of Q1. And now 2 is the top of the stack, so now if you get the top of the stack it is 2, and from top of you have to, for top of the queue, you're going to peek from the Q1. Okay, so that is how we're going to implement stack using two queues. Okay, let's quickly go ahead and write this program. So we're going to have two queues. So queue of integer, and I'm going to call this as q1, and I'm going to say linked list Okay, and queue of integer q2 equal to new linked list. Okay. So you can initialize these two in the constructor as well. So I've initialized it at the class also. Either way will work. So we'll initialize the top. Okay. So now in pop, as you can see, you can just refer. We can say int top equals and int return value, whatever we are going to pop it. So we are going to pop it from. So push operation is going to be costly, and pop operation is going to be uh, O of 1. Okay, so we've removed the element, right? So we have to make sure that we're maintaining the top element correctly. So if q1 it is empty, if this is not empty, right, then we've got a top element, otherwise the return value will be this thing, and so in that case top will be q1 dot pick. Okay, and then we're going to return value. Okay, so in q1 only we'll have the top, so we just have to q1 dot peak will give us the top value, and bool is empty, you can just refer it and return q1 dot is empty. Is going to say whether this is going to be empty or not. So then now let's implement the of one push operation. So what we're going to do is we are going to put this element in x, and basically this is our top element, top will be x, and while q1 is not empty, right, so we'll mimic the stack in q2. So q2 dot add and q1 dot remove. Okay, so we've now added everything, so we have to now swap it. So we'll have just a temporary stacks to do the swap. Temp we can say, and we'll just hold q1, and q1 will be equal to q2 and q2 is equal to temp. Okay, so that's it. So let me see whether I've got any spelling mistakes. I hope I've not got any spelling mistakes. Looks good. Let's run the program and see. There's a compiler error, so basically brackets have been improperly placed. So it's accepted. Let's submit it. Yeah, as you can see, it's success, and the runtime is 0 ms, which is faster than 100.0% of Java online submissions for implement stack using queues. Okay, so that's it, guys. So we're using two queues actually to implement a single stack. So whenever we encounter a new element, we'll put it in the queue2, which is usually maintained as an empty queue. As long as there are no elements in q1, we'll just go ahead and swap q1 and q2. There are elements in q1, we'll add it to the behind or the back side of the queue. So at any point q1 will be mimicking the stack, and you can take the top element from q1, you can pop it from q1. So q1 will support pop and top operations in O of 1, whereas in push we are doing certain swap operations, and we are doing copying of q1 to q2. So at the max we'll be swapping in -1 elements from q1, right? At any point of time you're going to insert one particular element into q2, and whatever elements that were there inserted, you're going to remove it and append it to q2, and then you'll swap it. So basically push operation is WOF. Yeah. Okay. Thanks, guys. I hope you like it. Bye.